Hi. So today I'm going to explain some additional information for you. So this is useful exclusively for JEE. Okay. Continuity of special types of functions. Continuity of special types of functions. In that, first one is continuity of the function in which signum function is involved. Continuity of the function in which signum function is involved. So I think you are familiar with signum function. Suppose f of x is equal to signum function of x. So it is defined as -1 for x less than 0 and is 0 when x is equal to 0 and is 1 for x greater than 0. Okay, so this is the definition of the signum function, and it is clearly discontinuous at 0. See here, it is clearly discontinuous at x is equal to 0. Signum function is discontinuous at x is equal to 0. So in general, signum of a function, suppose if the given function f of x, it is in the form of signum of, instead of x, some function say g of x is there. So when signum function of x is discontinuous when x is equal to 0, in the same way signum of g of x is discontinuous when g of x is equal to 0. G of x is equal to 0. Signum of x discontinuous at x is equal to 0 or when x is equal to 0. So signum of g of x is discontinuous when g of x is equal to 0. Suppose if g of x is never 0, then signum of g of x is continuous everywhere. Means continuous in its domain. Okay. So example problem. So it is clear that signum of g of x is discontinuous when g of x is equal to 0. If g of x is not equal to 0, then signum of g of x continuous function. Okay. So example, find the points of discontinuity of the function f of x. It is defined as signum of x cube minus x. So clearly the domain of this function is all real numbers. Okay, and we have to find the where this function is discontinuous. So from the above information, this function is discontinuous when this x cube minus x value is 0. So this f of x is discontinuous when this x cube minus x is equal to 0, because instead of g of x here what we have? X cube minus x. So signum of g of x is discontinuous when g of x is equal to 0. So in the same way, f of x is equal to signum of x cube minus x is discontinuous when x cube minus x is equal to 0. So x cube minus x is equal to 0. If you take x common, what you will get? X square minus 1 is equal to 0. Then on solving, what you will get the answer? X value 0 or x square is equal to 1. X square is equal to 1 means x is equal to what? Plus or minus 1. So thus the points of discontinuity of this function is 0, plus or minus 1. The points of discontinuity of this function are 0, plus or minus 1. How many points of discontinuity? 3 points of discontinuity. Next, look at next problem. So next problem, signum of, find the points of discontinuity of signum of 2 cos x minus 1. So here what is g of x? 2 cos x minus 1. So this function is discontinuous when 2 cos x minus 1 is equal to 0. So 2 cos x minus 1 is equal to 0. So implies that what you will get, cos x is equal to 1 by 2. So cos x is equal to 1 by 2. Cos of which angle is 1 by 2? Pi by 3. So cos x is equal to cos pi by 3. So pi by 3 is the one of point of discontinuity. But to get all points of discontinuity, so just you write the general solution of that trigonometric equation. What is the general solution? X is equal to 2n pi plus r minus alpha. What is alpha here? Pi by 3. And where n belongs to z. N belongs to z. So this function is discontinuous at x is equal to 2n pi plus r minus pi by 3, where n belongs to z. So the next question, f of x is equal to signum of x square minus 2x plus 3. So where this function is discontinuous. See here, we can simplify x square minus 2x plus 3 as x minus 1 whole square plus 2. Correct? Correct, Olivia? Okay, that means x minus 1 whole square is what? Some non-negative number plus 2. So 2 plus some non-negative number is always what? Positive. So for all real number x, this is some positive quantity. That means this quantity cannot be 0. So this quantity cannot be 0. Hence, this function is a continuous function in its domain. And the domain of this function is all real numbers. Or you can write it is equal to what? See, x minus 1 whole square non-negative plus 2 is positive. So 2 plus some non-negative is positive number. So signum of positive number is what? Equal to 1. You can argue like this also. So f of x is equal to 1, which is a constant function. So it is continuous function. Or you can argue like this also. So this quantity is never equal to 0. Signum of x square minus 2x plus 3 is always continuous function in its domain. The domain of this function is all real numbers. So next you take this homework. Next one more interesting problem. So f of x is equal to signum of 2 sin x plus a. So it is given, it is continuous for all x belongs to R. It is continuous for all x belongs to R. Then we have to find a value. It is given, it is continuous for all x belongs to R. So if it is continuous for all x belongs to R, then this inside the factor, inside the number should not be equal to 0. Just observe the above example. Okay. So if inside this, whatever the function is there, if that function not equal to 0, then this function signum of 2 sin x plus a will be continuous for all x. So f is continuous for all x belongs to R if 2 sin x plus a, 2 sin x plus a should not be 0. 2 sin x plus a not equal to 0. 2 sin x plus a not equal to 0. So that means two sin x plus a not equal to 0 means what you will get? Sin x, a is not equal to minus 2 sin x. So that means a should not be an element in the range of minus 2 sin x. So this implies that a does not belongs to the range of minus 2 sin x. Sin x range is minus 1 to 1. Minus 2 sin x range is minus 2 to plus 2. So a does not belongs to closed interval minus 2 comma plus 2. So this implies that a belongs to all real numbers except the numbers which are lie between minus 2 and plus 2, including minus 2 and plus 2. So these are some different model problem, and you try these problems So first problem, f of x is equal to signum of x square minus 3x plus 2. So you find the points where it is discontinuous. Okay. And the second problem, f of x is equal to signum of 2, or you take tan x minus root 3. So solve these two problems, homework. Okay. So find the points of discontinuity of these two functions. Okay. Next, continuity of the function. Continuity. So in special types of function, first is over, first model. So second model, continuity of the function involving limit n tends to infinity a power n. Continuity of the function involving the limit n tends to infinity a power n. So we know that it is equal to 0 for 0 less than or equal to a less than 1. It is equal to 1, a is equal to 1. It is infinite when a greater than 1. So we learned this formula even in limits also. Okay. So in limits I used x instead of n. So here they use the symbol n. Okay. However it may be, the variable there x, here n. Even you can write y, x, anything, no problem. See here, the function problem is given. Discuss the continuity of f of x is equal to limit n tends to infinity x power 2n minus 1 by x power 2n plus 1. Discuss the continuity of this function. Okay, f of x is equal to limit n tends to infinity x power 2n minus 1 by x power 2n plus 1. See, this definition f of x, whatever they have given, x power 2n is given, so I am adjusting that x power 2n as x square whole power n minus 1 divided by denominator x power 2n also x square whole power n plus 1. So is it correct? Yeah. So it is same as limit n tends to infinity 1 minus 1 by x square whole power n divided by 1 plus 1 by x square whole power n. Is it correct? Whether both are same? Yeah. So what I did, how we got this from this to this? Dividing numerator and denominator by x square whole power n. Correct only? Okay. So I will explain why I have written like that. Okay. Now here x square is some number, but we don't know what is that value. So depending on the x square values, you will get limit of this function. And remember, x square is always non-negative. That means x square is always greater than or equal to 0. Now here, if you observe, this x square whole power n is look like a power n. Correct? Suppose here this number x square, instead of a, what we have? X square. Suppose if this x square is lie between 0 and 1, okay. So if a is lie between 0 and 1, what is limit n tends to infinity a power n value? 0. Then limit n tends to infinity x power 2, x square whole power n value, what you will get? 0. So this part becomes what? 0. So 0 minus 1 by 0 plus 1. So 0 minus 1 by 0 plus 1, what will you get? Minus 1. Next, second case is what? A is equal to 1. So is it possible x square value 1? Yes, it is possible only. So second case, x square is equal to 1. So when x square is equal to 1, so that means when a is equal to 1, what is a power n value? 1. So here when x square is equal to 1, then x square whole power n value, what you will get? 1. So 1 minus 1, 0, by 1 plus 1, 2. So 0 by 2, what you will get? 0. Next, third case, when a greater than 1. Here x square greater than 1. So when x square greater than 1, then this a power n value is what? Infinity. That means when x square is greater than when x square greater than 1, then limit n tends to infinity, x square whole power n value is infinity. Correct? So now instead of this function is same as equal to this function same as this function also only, na? So in this case you consider this function, okay, because both are same only, na? So when x square greater than 1, then x square whole power n is tending to what? Infinity. So 1 by infinity, what you will get? 0. Here also 1 by infinity, what you will get? 0. So 1 minus 0 by 1 plus 0, what you will get? 1. Correct? So instead of using this definition of instead of using this function, I am using this function because both are same only, na? So if I use this, I will get directly limit of the function, find it easily. Okay? Okay. Now 0 less than or equal to x square less than 1. So further this function can be written as, look at this. Further this f of x can also be written as, so it is minus 1 for 0 less than or equal to x square less than 1. 0 less than or equal to x square less than 1 is same as minus 1 less than x less than 1. On solving this inequality we will get. Okay? And 0 when x square is equal to 1. X square is equal to 1 implies that x is equal to what? Plus or minus 1. And it is equal to 1 when x square greater than 1 is same as x greater than 1 or x is less than minus 1. On solving x square greater than 1 inequality, what you get? X greater than 1 or x less than minus 1. So observe clearly here doubtful points are 1 and minus 1. And obviously if you find left hand limit at 1 different from right hand limit. See, when extending to left hand limit, to get a left hand limit at 1, we have to use this definition. So according to this definition, what you will get? Left hand limit at 1? Minus 1. But what is the value of the 1? What is the value of the function at 1? 0. What is the right hand limit of the function at 1? 1. So LHL not equal to RHL and not equal to value of the function. So f is not continuous at 1. Similarly, f is not continuous at minus 1 also. So this function is discontinuous at 1 and minus 1. Is discontinuous at x is equal to plus or minus 1. This function is discontinuous when x is equal to 1 as well as minus 1. So there, for this function there are 2 points of discontinuity. Okay. Next, one more problem, similar problem. So discuss the continuity of the function f of x is equal to cos x whole power, limit n tends to infinity, cos x whole power 2n. Discuss the continuity of this function. Okay. Now here cos x whole power 2n, listen here, we can write it as like this also, no? Cos square x whole power n. Correct? Yeah. Now cos square x. So cos square x, what is the range of cos square x? It is always lie between 0 and 1. Both 0 and 1 are included. Is it possible this cos square x is greater than 1? Because it is look like limit n tends to infinity a power n. Instead of a, what we have? Cos square x. Here cos square x value may be lie between 0 and 1 or it may be equal to 1. But it is not greater than 1. So that means for this function we won't get 3 cases, we will get only 2 cases. First to 2 cases. First case is what? 0 to 1. Second case equal to 1. Okay. Third case greater than 1 is not possible here. Because here a value cos square x value cannot be more than 1. Okay. So thus it is equal to 0 when cos square x is lie between 0 and 1 0 included but 1 excluded, and its value is 1 when cos square x equal to 1. So it is equal to 1. Cos square x is equal to 1 is same as sin square x is equal to 0 only, no? So sin square x is equal to 0 implies that sin x is equal to what? 0. So then what is the, when sin x is equal to 0? For all integral multiples of pi. So that means cos square x value is 1. It is possible when x is equal to n pi, where n belongs to z or n belongs to I. That is, n is some integer. N is an integer. Okay. Then obviously in this case cos square x value is other than 1 only, no? So other than 1 means it should be, here in this case x should not equal to n pi. Okay, cos square x is equal to 1, it is when it is possible when x is equal to n pi. Then obviously cos square x value is here, in this case cos square x value is other than 1. So other than 1 means x will be other than n pi. Okay, that is x not equal to n pi. And if you observe clearly, this function is discontinuous at x is equal to n pi, because if you find limit of the function at n pi, what you will get? 0. But what is the value of the function at n pi? 1. Both are not equal. So limit of the function not equal to value of the function at n pi. So at n pi this function is discontinuous. So here f is discontinuous at x is equal to n pi. Suppose the same problem, instead of cos, sine is there. Here what you will get? Sine square. Here what you will get? Sine square x is equal to 1 and between 0 to 1. Because sine square x is also always lie between 0 to 1. So here also for sine square, if sine x whole power 2n is there, in that case also you will get only 2 cases. So our sine square x is equal to 1, if you solve that one, what you will get? X is equal to 2n plus 1 into pi by 2. So same problem, you take sin x and solve this problem, homework. Okay. Next one, continuity of functions in which f of x is defined differently for rational and irrational values of x. So how to find the, or how to check the continuity of the function when it is defined differently for rational values of x and irrational values of x. So I'll give one method, just you follow that method. Okay. So this is the third one. Suppose f of x is equal, it is defined like this. Its value is x if x is rational. If x is rational. And its value is 1 minus x if x is irrational. If x is irrational. So here the question is, check the continuity of the function. Okay, check the continuity of the function, or discuss the continuity of the function. Okay, check the continuity of the function, sorry, discuss the continuity of the function. Okay, discuss the continuity of this function. Okay, so here how to find where this function, at which points this function is continuous or at which points it is not continuous. So I'll give one method, just you follow this method. Suppose f is continuous, f is continuous at x is equal to a. Suppose, or let f is continuous at x is equal to a, then compulsory limit of the function as x tends to a, and here x takes only rational values, x belongs to q, x tends to a, must be equal to limit of f of x as x tends to a, and here x takes only irrational values. So here x is approaching to a and taking only rational values, and here x is approaching to a only taking irrational values. Okay. So then limit x tends to a. In this case, x takes only rational values. When x takes only rational, so instead of writing this, I am giving a notation. Okay. If x is rational means x belongs to Q. X is irrational means x belongs to Q dash. Okay. So when x takes only rational values and approaching to a, then f of x, what we have to take f of x in this case definition? X. And in the second case, what you have to take f of x definition, because here x takes only rational values. So from the given data, we have to take 1 minus x definition. Okay. Now apply the limit. What you will get here? A. Here 1 minus a. Now on solving this equation, what you will get? A value 1 by 2. A value, what you will get? 1 by 2. So that means this function is a continuous at 1 by 2 only. Means at the rest of the points it is discontinuous function. Okay. So this is the method to find the points where the given function is discontinuous. So that means where here when f of x is defined separately for rational values of x and irrational values of x. So if the given problem is like this, like that, then you have, this is the procedure to find the points where the function is continuous. Okay. Next, one more problem. So suppose here x square and this is 1. Next problem. So f of x is equal to x square if x rational number and is 1 if x is irrational number. So same steps. Let f of x is continuous at a, then limit x tends to a f of x when x takes rational values is equal to limit of f of x as x tends to a when x takes irrational values. So limit x tends to a when x takes rational values. What is the definition of the function? X square. So limit x tends to a when f of x takes irrational values. What is the definition? 1. And applying the limit, what do you get? A square is equal to 1. A square is equal to 1 means a is equal to what? Plus or minus 1. So thus this function fx is continuous at plus or minus 1. So simple shortcut, just equate these two. Just equate these two definitions and solve for x. Okay. Or remember this procedure. Next, third problem. Here it is given 0 and here it is given 1. That means f of x is equal to 0. F of x is equal to 0 if x is rational and is 1 if x is irrational. So same steps. Then what you will get? Limit x tends to a when x is a rational, function value is 0, function definition is 0. When x tends to a and x takes only rational values, function definition is 1. Then applying the limit, what you will get? 0 is equal to 1. So 0 is equal to 1. Is it true? So it is false. So it is false. It is false means this function is not continuous at a. Not only at a, it is not continuous at any real number, because here a is some arbitrary constant. So if it is not continuous at a means it is not continuous everywhere. Okay, that means it is nowhere continuous. It is discontinuous everywhere. Okay. So then you take homework, same model. So this definition is x and this definition is minus x. F of x is x if x is rational. F of x is minus x if x is irrational. Next, fourth type. So continuity of composite functions. Continuity of composite functions. So you are familiar with this. If f is a mapping from a to b, if f is a function mapping from a to b, and if g is a function mapping from b to c, then g circle f is a mapping from where to where? A to c. Okay? Next. If f is continuous at x is equal to a, if f is continuous at x is equal to a, and if g is continuous at x is equal to f of a, because in the domain of f, if you take an element in the form of a, in the domain of g, an element in the form of f of a, because this is the codomain for a, correct only, na? So if I take an element, so it is in the form of a f of a. Okay. So if f is continuous at x is equal to a, and g is continuous at x is equal to f of a, then for g circle f, what is the domain? X, capital A only, na? The domain of g circle f is same as the domain of f. So that means g circle f is continuous at x is equal to a. Okay, if f is continuous at a, g is continuous at x is equal to f of a, then g circle f is continuous at x is equal to a. So example I am taking. For example, f of x is equal to x square. It is continuous at x is equal to 0. And g of x is equal to sin x. So it is continuous at at x is equal to f of 0. So f of 0 is nothing but 0 only. Then g circle f, it is equal to sin of x square. It is continuous at x is equal to 0. X square is continuous at 0. Sin x is gx is equal to sin x is continuous at x is equal to f of 0. Then g circle f of x is sin of x square is also continuous at 0. Okay. And here one important note point you remember. You remember one important point. Okay. Suppose if f is discontinuous, at x is equal to alpha, and g is discontinuous, and g is capital G function, g of x is discontinuous at x is equal to beta, then g circle f, nothing but g of f of x, g circle f of x, g circle f of x or g of f of x is discontinuous when x is equal to alpha and f of x is equal to beta. See now, g of f of x. So it is discontinuous when f is discontinuous. At which points f is discontinuous? At x is equal to alpha. And g of x is discontinuous at x is equal to beta. Then g of f of x is discontinuous when f of x is equal to beta. Okay, f of x is discontinuous at x is equal to alpha. So g of f of x, now first you are applying f function. So that means this g of f of x is discontinuous at the points where f is discontinuous, where it is discontinuous when x is equal to alpha. But g function is discontinuous at x is equal to beta. G of x function is discontinuous at x is equal to beta. G of y is discontinuous at y is equal to beta. Like that g of y, like nothing but f of x is discontinuous when y is equal to beta, nothing but f of x is equal to beta. So on solving this equation, you will get some more x values. Okay. So obviously, you tell me now, what about f of g of x? So f of g of x is discontinuous when x is equal to, first g function is applying. So f of g of x is discontinuous whenever g function is discontinuous. When it is discontinuous, x is equal to beta. F of x is discontinuous at x is equal to alpha. Then f of y, nothing but f of g of x is discontinuous when y is equal to alpha or when g of x is equal to alpha. Okay. So one problem. So example. So f of x is equal to x minus 1 by x minus 2. G of x is equal to, this is x plus 1 by x minus 1. G of x is equal to 1 by x minus 2. So discuss the continuity of the functions f, g, g circle f and f circle g. Okay. So clearly both functions are rational functions. So both are continuous in their domains. That means they are discontinuous at the points when those functions are not defined. That means when denominator is equal to 0. So this function is not defined when this denominator x minus 1 is 0. That means x is equal to 1. So f is discontinuous at x is equal to 1. Similarly, g is discontinuous when x is equal to 2. When denominator equal to 0, that is x is equal to 2. So then obviously g of f of x is discontinuous when x is equal to, where f is discontinuous at 1, and where g function is discontinuous, x is equal to 2. X is equal to 2. Instead of x here, what you have? F of x. So when f of x is equal to 2. So f of x is what? X plus 1 by x minus 1. It is equal to 2. So on solving you will get x value 3. So thus g of f of x is discontinuous at x is equal to 1 as well as at x is equal to 3. So I am not finding g of f of x. Okay, just remembering those points. Then you tell me now, what about f of g of x? So f of g of x is discontinuous at x is equal to, where g function is discontinuous, 2, and where f function is discontinuous at 1. So f of g of x is discontinuous when g of x is equal to 1. So g of x is equal to 1. 1 by x minus 2 is 1, means what you will get? X value 3 only. So f function discontinuous at 1, g function discontinuous at 2, g of f of x is discontinuous at x is equal to 1 and 3, f of g of x is discontinuous at x is equal to 2 and at x is equal to 3. And in this model you take one example. Homework is f of x is equal to x minus 2 divided by 2x minus 3, and g of x is equal to 2 upon x minus 1. So same model. So you check the continuity of this function, f of x function, g of x function. That means, find the points of discontinuity of f of x, g of x, g circle f, f circle g. Thank you.